I would like to talk to you about the oxides of nitrogen and phosphorus. Dear students, I am Dr. Digna. Contents of the presentation is oxides of nitrogen, acidic strength, structure of oxides of nitrogen, oxides of phosphorus, its acidic strength and its structure. Oxides of group 15 elements. All these elements form two types of oxides, E2O3 and E2O5. Here E represents nitrogen, phosphorus, arsenic, antimony or bismuth. These are the general formula of E2O3, that is N2O3, P2O3, As2O3, Sp2O3 and Bi2O3. The oxides in the higher oxidation state of the element is more acidic than that of the lower oxidation state. Acidic character decreases down the group. Acidic strength of oxides decreases down the group. That is, more acidic is N2O3. And here the acidic ones are N2O3, then comes Phosphorus Trioxide, then arsenic and antimony. Oxides are amphoteric in nature. Amphoteric means they can behave like both acids and bases. And Bi2O3 is basic in nature. So acidic character decreases down the group from nitrogen to bismuth. The +5 oxides are more acidic than the corresponding +3 oxides. In these oxides, the oxidation state of the element like nitrogen, phosphorus, arsenic, antimony and bismuth is in +3 oxidation state, while in the case of other oxides having the general formula E2O5, that corresponds to N2O5, P2O5, As2O5, Sp2O5 and Bi2O5. In this case, +5 are their oxidation states. Therefore, N2O5 is more acidic than N2O3. This is the acidic character of the oxides of group 15 elements. All the elements of group 15 can form two types of oxides generally, that is E2O3 and E2O5. Among them, E2O5 is more acidic than E2O3 type because the +5 oxidation states containing oxides are more acidic than the corresponding +3 oxides. Nitrogen and phosphorus form other oxides too. The structures of the oxides of nitrogen and phosphorus are briefly discussed here. Now we are moving to the topic oxides of nitrogen. Oxides of nitrogen are mixture of gases that are composed of nitrogen and oxygen. Nitrogen oxide may refer to a binary compound of oxygen and nitrogen or a mixture of such compounds. The oxides of nitrogen are named here, that is nitric oxide or nitrogen monoxide. Next one is nitrogen dioxide and nitrogen trioxide or nitrate radical, nitrous oxide, that is N2O, dinitrogen dioxide N2O2, dinitrogen trioxide N2O3, dinitrogen tetroxide N2O4, dinitrogen pentoxide N2O5 or nitronium nitrate, nitrosyl azide N4O, oxatetrazole N4O, trinitramide NNO2 thrice or N4O6. Nitrogen forms several oxides. In all oxidation states of nitrogen ranging from +1 to +5. Here we are discussing some important oxides of nitrogen only. First one is nitrous oxide. Its other name is Dinitrogen Monoxide. It has a oxidation state +1 in this particular molecule, that is oxygen has -2 oxidation state, so nitrogen with +1 oxidation state. It is a colorless gas and it is diamagnetic in nature. That means it has no unpaired electrons in its molecular orbital. And its melting point is -85 degrees Celsius, boiling point is -88 degrees Celsius. It has a linear structure. The linear structure is shown in this figure, and nitrogen-nitrogen bond length is 113 picometer, nitrogen-oxygen bond length is 119 picometer, and its bond angle is 180 degree. It also shows its a resonant hybrid of two resonance structures, that is N triple bond N plus O minus in equilibrium with N minus double bond N plus double bond oxygen. Nitrous oxide, commonly known as laughing gas or happy gas or simply nitrous. Nitrous oxide has significant medical uses, especially in surgery and dentistry, for its anesthetic and pain reducing effects. Its colloquial name, that is laughing gas, coined by Humphrey Davy. Humphrey Davy was a British scientist. He experimented himself and his friends with this particular gas. One of his friend, a poet, his name was Robert Southey. He wrote, "I am sure the air in heaven must be this wonderful working gas of delight." He coined this name like laughing gas due to the euphoric effects experienced by himself and with his friends upon inhaling it. A property that has led to its recreational use and as a dissociative anesthetic. Nitrous oxide cause euphoric effects. What is euphoria? Euphoria is the experience of pleasure or excitement and intense feelings of well-being and happiness. Nitrous oxide is effective as a sedative because it relaxes patients with the pleasurable feelings it emits. Another important oxide of nitrogen is nitric oxide. It's also known as nitrogen monoxide. Nitric oxide, the nitrogen shows +2 oxidation state, oxygen shows -2, and nitrogen shows +2 oxidation state in this molecule. Like nitrous oxide, it is also a colorless gas, but it is paramagnetic. That means it has an unpaired electron in its molecular orbitals. It shows melting point at -140 degrees Celsius. It has a boiling point of about -152 degrees Celsius. Its structure is linear and it is prepared by when sodium nitride treated with ferrous sulfate in presence of sulfuric acid, giving ferric sulfate with sodium bisulfate, water and nitric oxide is formed. Structure is linear and nitrogen oxygen bond length is 115 picometer, and it shows a resonance structures like this: nitrogen double bond oxygen with an unpaired electron with oxygen here, that is in equilibrium with nitrogen double bond oxygen the unpaired electron with nitrogen here. That is, the unpaired electron in the molecule is shared over the whole molecule. Molecules such as nitrogen monoxide, which contain unpaired electrons, are referred to as odd electron molecules. The presence of the odd electron makes such molecules paramagnetic. Because of this unpaired electron, this molecule is said to be paramagnetic. However, the properties of nitrogen monoxide differ significantly from the other odd electron molecules. For example, at room temperature, it shows little tendency to dimerize, a process which would have resulted in the pairing of the odd electron. In the gaseous state, nitric oxide has a linear structure, but in the solid state it shows a dimeric structure. So in this case it acts as a diamagnetic, and in this case it acts as a paramagnetic. Here the nitrogen oxygen bond length is 2.40 angstrom, that is 240 picometer, and here the nitrogen oxygen distance is 1.14 angstrom, that is 114 picometer. Nitric oxide forms in combustion systems and can be generated by lightning in thunderstorms. In the 1998 Nobel Prize in Physiology or Medicine was awarded for discovering nitric oxide's role as a cardiovascular signaling molecule. What is cell signaling? In biology, cell signaling is a part of any communication process that governs basic activities of cells and coordinates multiple cell actions. Important nitrogen dioxides shown here is one is N2O3 and one is NO2. First we are discussing N2O3. N2O3 is dinitrogen trioxide. In this molecule, oxygen shows -2 oxidation state and nitrogen shows +3 oxidation state. It is a blue solid or blue liquid at extremely low temperature. It is diamagnetic in nature and it dissociates reversibly in gas phase into nitric oxide and nitrogen dioxide. Its melting point is -100 degrees Celsius and its boiling point is 4 degrees Celsius. It has a planar structure which is shown here, and nitrogen-nitrogen bond distance is 186 picometer. Nitrogen-oxygen bond distance is 114 picometer, and here nitrogen-oxygen bond distance is 121 picometer. It shows three different angles. One is oxygen-nitrogen-oxygen having 130 degree, and oxygen-nitrogen-nitrogen having 117 degree bond angle, and oxygen-nitrogen-nitrogen shows 105 degree bond angle. It has a resonance structure shown here, nitrogen with the positive charge and oxygen with the negative charge here. Here the oxygen negative charge and nitrogen positive charge. Nitrogen dioxide is an important oxide of nitrogen, and in this particular molecule nitrogen shows +4 is its oxidation state. It is a reddish brown gas. It is paramagnetic in nature. It can dimerize reversibly to nitrogen dinitrogen tetroxide. Nitrogen dioxide can be prepared from nitric oxide, reacts with oxygen giving nitrogen dioxide. It has a planar angular or planar bent structure ONO with a bond angle 134.3 degree and bond length is about 119.7 picometer. In some textbook it is approximated as 120 degree. picometer. Nitrogen is a reddish brown gas. NO2 is an intermediate in the industrial synthesis of nitric acid, a yellowish brown liquid below 21.2 degree, and converts to the colorless dinitrogen tetroxide in 2O4 below minus 11.2 degrees Celsius. It is a paramagnetic in nature. Its resonance structure is shown in this here. Here the nitrogen having one unpaired electron and the nitrogen having one unpaired electron. So it behaves as a typical odd electron molecule and therefore undergoes dimerization to form stable diamagnetic N2O4 molecule with even number of electrons. Here discussing two important oxides of nitrogen, that is N2O4 and N2O5. N2O4 is dinitrogen tetroxide. In this molecule, nitrogen shows +4 oxidation state. It is actually the dimeric form of nitrogen dioxide and it is a colorless gas. It is diamagnetic in nature. Its melting point is minus 11 degrees Celsius. Its boiling point is 21 degrees Celsius. It has a structure planar molecule. Here the nitrogen distance is 175 picometer and oxygen oxygen bond angle is 135 degree and nitrogen oxygen bond length is 121 picometer. It shows two resonance structures, that is nitrogen with positive charge and two oxygen with negative charges. One is in the cis position and the other is in the trans position. Dinitrogen Pentoxide, its molecular formula is N2O5. Its oxidation state is +5. It is a colorless solid. It is diamagnetic in nature. Its melting point is 30 degrees Celsius. It sublimes at 32 degrees Celsius to molecular state. It has a planar structure having the resonance. Here the nitrogen bond angle is 112 degree. Nitrogen oxygen bond length is 119 picometer here and nitrogen oxygen bond length is 151 picometer here and the oxygen bond angle is 134 degree. It also shows two resonance structures, that is nitrogen with a positive charge and two oxygen opposite to nitrogen is minus charge and here the two oxygen cis to nitrogen, that is minus with minus charge. These are the important oxides of nitrogen. Its oxidation number ranging from +1 to +5. The most acidic one is N2O5. Phosphorus forms several oxides. Of these, the most established are phosphorus oxide, phosphorus trioxide, that is P4O6, and phosphorus pentoxide or phosphoric anhydride. Here the two important oxides of phosphorus is shown here, that is P4O6, that is known as phosphorus trioxide or phosphorus anhydride. In this particular molecule, phosphorus show +3 oxidation state. It is a colorless volatile solid. Its melting point is 24 degrees Celsius and its boiling point is 174 degrees Celsius. Its structure is shown here, that is phosphorus, then comes oxygen, then phosphorus, oxygen, phosphorus, oxygen, phosphorus, oxygen, oxygen, phosphor, oxygen, phosphor. Phosphorus, then comes oxygen, then comes phosphorus. So alternate position occupied by phosphorus and oxygen here. The bond angle between phosphorus, oxygen, phosphorus is 127 degree and bond length is between phosphorus and oxygen is 166 picometer approximately, and here the bond angle is 99.5 degree. And next phosphorus oxide is phosphorus pentoxide. It is also known as phosphoric anhydride, and in this molecule phosphorus shows +5 oxidation state. Phosphorus pentoxide exists as a dimer, that is P4O10. It is a white deliquescent solid. Deliquescent means to become or a tendency to form a liquid, that it can absorb moisture molecule. It is acts as a dehydrating agent. It can absorb water molecules and it is converted to liquid. So it acts as a deliquescent solid. And its structure is shown here. In this, phosphorus oxygen bond length is 143 picometer and phosphorus oxygen distance is 160 picometer here, and the bond angle between the oxygen phosphorus oxygen is 102 degree, and here the phosphorus oxygen phosphorus is 123 degree. So here the phosphorus oxygen in its oxygen with the double bond is bond length is 143 picometer, and for the single bond it's about 160 picometer. That is, terminal phosphorus oxygen bond length is 143 picometer. Phosphorus oxygen bridge length is 160 picometer. Here showing three other oxides of phosphorus, that is P4O7, P4O8 and P4O9. In these molecules, phosphorus shows two different oxidation states, that is +3 and +5, that is mixed P3 and P5 species. Each phosphorus center bearing a terminal oxo group, that is the structure is shown this, and here this phosphorus contains one oxo group, terminal oxo group, with the being oxidized to phosphorus in the +5 oxidation state, while other three phosphorus remains in the +3 oxidation state. Structure is closely related to phosphorus pentoxide, that is P4O10. P4O8, that is also similar to the P4O7. In this structure, two oxo groups, and here the two phosphorus with the oxidation state +5 and the remaining two phosphorus atoms with +3 oxidation state. And in the case of P4O9, here three terminal oxo group and having phosphorus with the +5 oxidation state, and the remain one phosphorus atoms with phosphorus +3 oxidation state. So these are the important oxides of phosphorus, that is P4O6, P4 O10, P4O7, P4O8, P4O9. Among them, P4O7, P4O8 and P4O9 are the mixed oxides. That means it contains +3 and +5 oxidation states of phosphorus atoms. That's all I have to say about the oxides of nitrogen and phosphorus. Thank you for your attention.